Chapter 6 is going to start out with this first lesson talking about relations and functions. And so we are going to define what a relation and what a function is, determine whether relations are functions, and describe patterns in mapping diagrams. Our vocabulary here that we're going to see throughout this lesson is going to be input, output, relation, mapping diagram, and function. And we're going to get more into these as we go throughout the lesson. The first two we're going to go ahead and touch on are going to be inputs and outputs. We usually think about a drink machine, putting money in and getting a drink out, or breathing, putting oxygen into our body and putting the carbon dioxide out. And so what I want you to notice is that we have these ordered pairs listed here. If you notice how the blue ones are going to be our inputs, and those are our x coordinates. So anytime you see an input, they're also talking about an x coordinate. And the same thing with the outputs. It's always that second number there. And so the outputs are always going to be our y coordinates. And so whenever you hear those terms, input, output, they're also talking about your x and y coordinates. Okay, so our key idea here is talking about these relations. And this says that a relation pairs inputs with outputs. Well, we know that when we have a pair of one input and one output, that's our ordered pairs. So sometimes you'll also hear a relation known as a set of ordered pairs. So we're just going to add that note here. Or a set of coordinates. And so sometimes we're going to look at relations as ordered pairs, and sometimes we're going to look at them on a mapping diagram. And so we've got both of those here. The ordered pairs is just what we're used to seeing. When we have this mapping diagram, I want you to notice that they have these two kind of rounded boxes here. Our inputs are listed. You can see over here our inputs are 0, 1, and 2, and they have 0, 1, 2 listed. Our outputs are listed on the right, 1, 2, 4, and there's a 1, 2, 4 here. And one really important part of the mapping diagram is if you notice that they have a ray that is connecting each input to its output. And I say array because it does have the arrow on one end, because we are saying this input goes to this output. This input produces this output. This input produces this output. And so that ray in there is very, very, very important. So whenever we have a mapping diagram, sometimes they're going to ask us to list the ordered pairs. And we know that an ordered pair is an x and a y. And so basically what you do, you come over here to your input and you choose your x. And so in this case it's 1. And you follow that ray, and we know that the output would be 3. On this one, our input is 2 and our output is 6. The next one, our input is 3. And if you follow that ray over, your output is going to be 9. Input of 4, output of 12. And so it's pretty simple. If you look at the next one, if you look at our example B, you notice that the lines are kind of crossing over each other, and it looks like it's going to be a little bit more difficult, but you do the same thing. You choose your input. For example, this is a 0. You follow that ray, and its output is also 0. So it's not necessarily what's straight across from it, it's where is that ray leading you to. If you look at 2, 2 actually has two outputs. It has an output of 1, and 2 also has an output of -2. And if you'll notice, we listed those as two different coordinates. And we also have an input of 4 that produces an output of -3. One way you can make sure that you get all your coordinates is always start at the top and work your way down. Make sure you don't miss anything. Another way is if you see we have 1, 2, 3, 4 lines, that means we have 4 pairs, which have 4 coordinates. Same thing on this one, you can count your lines. You have 4 lines, so you're going to end up with those 4 coordinates. So you can try these two, pause the video, see what you can do, and then come back and we'll work it together. All right, on this one, you should have listed your ordered pairs as 0, 12, 2, 10, 4, 8, and 6, 6. These are easy. You just go straight across. On the second one, we only have 2 inputs, but we have 4 outputs. So if you look, you have an input of 1 with an output of -1. You have a totally different coordinate with an input of 1 with an output of -2. You have an input of 2 with an output of -3. You have a different coordinate with an input of 2 and an output of -4. Now, when we have these relations or these sets of ordered pairs, some of them can be very special, and we call those special relations functions. And so if you have each input pairs with exactly 1 output, then it's going to be a function. So each input must go out to 1 output. And if we take a look at these examples that we just did, look at this input. It has 1 output, 1 output, 1 output, 1 output. So this would be considered a function. But if you look at number 2 that you just did, see this input 1? It has an output of -1 and an output of -2. So because this one input has 2 outputs, then this would not be a function. And it's just as simple as that. Now, whenever you look at these, one kind of trick that you can remember is that your x coordinates can't repeat. And let me show you what I mean by that. If we have coordinates of 1, 2, 3, 4, and we have y coordinates of 1 and 3. And so we have, let's say we have 1, 1, and 2, 1, and 3, 3, and 4, 3. Our y coordinates repeated. This 1 repeated and this 3 repeated. And that's okay because each of these inputs still only has 1 output. But if we have something like 1, 2, 3, and then on our output side we have maybe a 2 and a 6. And we have 1, 2, 1, 6, 2, 6, 3, 6. This would not be a function because of this 1 repeating right here. This input of 3 has 1 output of 6. The input of 2 has 1 output of 6. It's okay for them to both have the same output, but this 1 has an output of 6 and an output of 2. And it can only have 1 output to be a function. So if we look at these, it says, consider the mapping diagram at the left. Determine whether the relation is a function. So you come over and you see is each input paired with 1 output, and it is. So yes, this is a function. B says describe the pattern of inputs and outputs in the mapping diagram. They're not asking us to describe how the input affects the output, just what's the pattern going on here. And if you look, our inputs are increasing by 1. 1 plus 1 is 2, plus 1 is 3, plus 1 is 4. What are you doing to this number to get to the next number? That's what they're asking for in the pattern. So if you do your patterns of outputs, 15 plus 15 is 30, plus 15 is 45, plus 15 is 60. And so our pattern is that they're adding 15 each time. All right, so try these couple and see what happens. All right, they're asking us to determine whether the relation is a function. And so if you look at number 3, this input has 2 outputs. So you know right off the bat that this is not a function. Now it doesn't ask us to explain, so we don't have to write it, but if you were explaining, you would say that the input of -1/2 has multiple outputs or something along the lines of that. If you look over here at number 4, each input has exactly 1 output, so you would say, yes, this is a function. Number 5 says describe the pattern of inputs and outputs in the mapping diagram in On Your Own 4. Well, this is On Your Own number 4, and so if you're looking at your pattern of inputs, you can see that this is increasing by 2 every time, So our inputs are increasing by 2. And our outputs, you can see it's decreasing by 3 every time. So you would say that your outputs are decreasing by 3.